We're going to move on to section 11.2 now, which is dealing with inference for the mean for two means when they're dependent samples. And just a reminder, what do dependent and independent samples mean? Independent is, and again, this is just a rule of thumb, but an independent sample is when you have two independent groups, but you only measure them one time. Dependent samples tend to mean, not often, not always, but often mean that you're going to have one group and you're going to measure them twice, say at the beginning, at the end, or something like that, or a husband and a wife. All right, so decide whether the sampling methods below are independent or dependent. So the accuracy of verbal responses is tested in an experiment in which individuals report their heights verbally and then they are measured. Okay, so that's a dependent sample, right? Because you asked them and then you measured it. So you're measuring them twice. You're measuring what they thought their height was and then what it actually is, but it's one group measured twice. And what you're measuring about them is quantitative, right? Because its unit is inches. Numbers. It's not how they feel about something. It's not their favorite Olympic sport. It's their height. All right, now what about we want to conduct a study to compare the differences in prices between name brand and store brand merchandise at a local store. Name brand and store brand items of the same size and type are purchased from each of the following 6 categories: paper towels, shampoos, cereal, ice cream, peanut butter, and milk. Okay, again, this is dependent. You're taking one group of items, namely shampoo, ice cream, peanut butter, and so on, and you're measuring it twice. You're measuring it as a name brand thing and as a store brand thing. That's dependent. I mean, and it just makes logical sense. Just never forget, the logical part of this. Dependency means that what you get as an outcome for the second thing depends on what the first thing was. A store naturally looks at what the name brands charge for it and make their store brands a little bit less, right? So there's a relationship there. And of course, also, by the way, this is quantitative because it's money, money, money. Money is a quantitative thing. All right, that's good with that. Now we're going to test some hypotheses. So a study was carried out to determine whether Reiki touch therapy was useful in reduction of mean pain level in chronic pain sufferers, including cancer patients. So the pain level reported by a random sample of 13 patients before and after Reiki touch therapy is shown in the table. We're going to use the results to determine whether there was a reduction in pain. Okay, so first of all, why is this a dependent sample? Well, it's one group of people measured twice, right? So they're measured before and after the touch therapy. So what's their pain level before? What's their pain level after? Okay, so there we go. Now we're going to find the differences, and I'm going to totally use Excel. So I just kind of copied and pasted into Excel right here. And I'm going to use a simple formula to do this. We want after minus before. I think that was set up in the problem. You don't always. Yeah, I just said what to do. And again, it's sort of like the stuff we ran into before. It kind of doesn't matter which one you pick. You just want to be consistent. So I did after minus before, and now I'm going to drag it across. There are all the values. So I'll go paste those back into my notes. You will, of course, be writing them by hand because that's just it. Now we need to find d bar and the standard deviation of the d. So these are all the differences d. I guess I could say differences d. Then we need to find all the mean of those. That's d bar, and the standard deviation of all of those. Hold on one second. I don't particularly like what that looks like. There we go. Okay, so I obviously already found them, but you're going to find them. And we already know how to do this. To find the average, the mean, you just take average of those values. There's your d bar. Standard deviation is STDEV. For me, because I have the new Excel, it's .s, but the old Excel, it's just STDEV. I personally like the .s because it reminds me this was a sample. There we go, 1.605. So that's the mean, that's the standard deviation. So I'm going to put those right back in here. There we go. All right, now we need to test the hypotheses. And you'll notice that when you look at these lovely 6 steps that are nothing like all the other 6 steps you've seen, sarcasm, sarcasm, sarcasm. All right, they're very, very similar. This is a t-test now because we're working with either small samples or values, where we don't know sigma. When you don't know sigma, you're stuck with the t distribution, which is what we've got. And we can use technology to help us, and we will. All right. And then this is extremely, I gotta tell you, this one's really similar to what we did before. So suppose we are going to conduct that test, keeping in mind that we found the differences as after minus before, and that means that group 1 is going to be after, group 2 is before. It didn't have to be that way, that's just how this problem was set up. Okay? So we want to know, was there a reduction in pain? So is after smaller than before, right? So, as a matter of fact, I'll type that up. We want to know if after their pain level after the touch therapy is less than before. In other words, group 1 is less than group 2. That's why I set up the alternative hypotheses the way that I did, where mu1 is equal to mu2, that's null, and mu1 is less than mu2 for the alternative. If I had set it up the other way, where it was before minus after, then this sign would be reversed, right? So make a note of that somewhere. Note, if the difference was before minus after, then the alternative hypothesis would have been, oh, let me just copy and paste this in. Okay, that's another little note for us. All right. What results do we expect from the hypothesis test based on the plot of the before and after pain levels? So you can see down here, I used Minitab to draw a box plot of each of them. So here's the pain levels before the touch therapy. Here's the pain levels after. And hopefully you can see it seems like there's a significant drop in pain levels, right? Do you see how the median for the after is below, heck, it looks like it's even below the minimum, but definitely below Q1 of this other guy, right? So it seems like after really plummeted. The pain levels seem to really plummet. Pain levels seemed to really plummet after the touch therapy. So we expect to reject the null hypothesis. Now, we don't know if that's true or not, but that's what we're expecting. All right, now, the following is a normal probability plot of the differences. Is conducting a hypothesis test and these data possible? Absolutely. Data is normal. Everything's great, right? Got to know it's normal because back here it says you've got to have normally distributed or a large enough n. We didn't have a large n, so we had to prove that it was normal, right? I'll make a note of that. We had to show this because we were not informed, oopsie, that the data was normal. Oh, hold on one second. There we go. In the original problem, and n is less than 30. All right? Cool. All right, so let's do this test. So, oops, sorry, I paused it on you there, but we need to go back. I just remembered something about example 3a, so which is where we're at, I know, in example 3. But okay, remember how I was saying we needed the alternative to be mu1 is less than mu2. And also remember we learned before that you could rewrite that this way with the subtraction in it. Okay, so what we're going to do now is we're going to write it with, oopsie, mu d is less than 0. And mu d equals 0. That'll be the null hypothesis, okay? Because when you're talking about the difference, you're talking about that subtraction, right? So this is our actual answer. We want the null hypothesis to be this, and we want the alternative hypothesis to be this, okay? So those two things together make our null and alternative hypotheses, all right? Okay, so back for A, if that's true for A, back here, sorry about that, that's why we have this right here, that the difference is equal to 0 and that the difference is less than 0. And I'm not sure why I put little bars over those D's. That's not true. It's just D, the mean of the difference, the mean of the difference, all right? All right, alpha is equal to 0.05. Okay, then you just need to find that test statistic, which is d bar over st, blah, blah, blah. All right, now the long way is to do this the way we're doing it, right? But the better way would be to take StatCrunch and kind of make our lives go a lot faster, don't you think? To find this -4 and all that jazz. So let me bring up StatCrunch. Hold on. There it is. All right, we want to go to stat. Oh no, we want to type in these numbers. Hold on, we better find these again. All right, so these are the differences that I've got from Excel. All right, I'm going to teach you a little trick because I like it to be all in one column in StatCrunch. All right, I copied those differences. Now I'm going to right click. I'm going to choose Paste Special. I'm going to click transpose, and values. You only want values because you don't want it to keep all the formulas because then that won't work. You want to click values and transpose. There, I've got them. So I'm going to copy those now. Control C, go to StatCrunch. There it is. Control V, there's the differences. All right, cool. So then you can go to Stat, T statistics, one sample. You've got data this time, so click with data. And you wait. There you go, difference. Next. We're testing less than, so I'm going to pick the less than 0, calculate. And there it is. I want to show you the other way to do this as well, because this is just pretty awesome. So, you know how we went to all that trouble to find the differences? Well, what I went in here and typed before and after and such. All right, you go to Stat, go to T Statistics, choose Paired. See that? It's going to say, hey, where's sample 1? Now remember, we picked sample 1 to be the after sample, right? And then sample 2 was before. Okay. And then if you want, you can save the differences. So I can click that and then say next. I want it to be less than. Click calculate. There it is. And look, it found all the differences for us. Cool. So if you want, you could just use StatCrunch for the whole thing, I guess. Copy. Take that back to Excel and paste it in for our technology assignment. And you can see right here that tells us it was after minus before. So I'm going to save this. Control save, Control S. That way I've got it. Cool. So you can see there's that test statistic, -4.139434, just like I said in the notes back here. -4.139. And that p-value was 0.0005 according to StatCrunch. So I've got it as 0.000489, but that's because Minitab does all those decimal places for us. And then we're going to reject the null hypothesis as usual. When you have a p-value that's less than your alpha, you're going to reject. I'm going to change this so that's like that. All right, and that means there is enough evidence to support the claim that the average pain was lower after the Reiki touch therapy, which shouldn't come as any great shock to us because we could see their pain levels were much lower after than they were before, but we just proved it. Now real quickly, what are we supposed to do if we're supposed to do the classical method? Well, everything else would be the same, right? Except you need degrees of freedom is 12. You grab from your T table, which is down here. T table, you say, okay, 0.05 is in the tail because it's left-tailed, so you don't have to split it in half. Go down to 12, that's 1.782, but since it's left-tailed, you got to make it negative. Oops. I'm just going to kind of label that for you so you can see it. There you go. So this is alpha over here. This is negative T alpha, which is negative 1.782. So we reject because our test statistic, which is this guy right here, T0, was negative 4.319. Oopsie. Was less than that negative T alpha, which was negative 1.782. Oopsie. I think that's what it was. Yep, that's what it was. All right, we're all done with that. Next time I see you, we'll be reading some computer output. See you then.